What is the determinant of a matrix? This is clearly one of the most important topics in matrices, and we need to understand it really well. How do we write the determinant of matrix A? It's written like this: A between two vertical bars. This is the determinant of A. Do not confuse this with the absolute value. Every matrix has a determinant and it's unique. The determinant of a matrix is a unique number which can be calculated. It's special because it has a wide range of applications. We can use it to find the area of a triangle, the inverse of a matrix, or even to solve linear equations. If you remember, we had used elementary operations to solve for the inverse of a matrix. And the procedure was super lengthy. And determinants make it super easy. If we have a matrix A, its determinant is written like this. The elements will be written between the two vertical bars. And the last thing we need to know about the determinant of a matrix is that it can calculate only square matrices. Yes, it'll work only for matrices of the order 1 by 1, 2 by 2, 3 by 3, and so on. But how do we calculate the determinant of a matrix? We will cover that in the next part of the lesson. How do we find the determinant of matrix A? It is a 1 by 1 matrix, one row and one column. What is the determinant of A? As there is just one element in the matrix, it will be written as the determinant of that element. Determinant of 2. What is this equal to? The determinant of 1 by 1 matrix is equal to the only element that is present in the matrix. Here the only element is 2, hence the determinant of matrix A will be 2. This is the determinant of matrix A. Do not misinterpret it as the absolute value of 2. Okay, next question. What will be the determinant of matrix B? The determinant of B is written like this, and it will equal the determinant of -1. The determinant of a 1 by 1 matrix is equal to the element inside it. It will equal -1. It's the determinant of matrix B. Is finding the determinant really that easy? What if it's a 2 by 2 matrix? Let's see. Matrix X is a 2 by 2 matrix. 2 rows, 2 columns, and 4 elements. What will the determinant of X be equal to? Now this is a 2 by 2 matrix. The way in which we find the determinant is totally different from the way in which we find the determinant of a 1 by 1 matrix. It will equal the product of these two elements, that's A times D, minus the product of these two elements, that's B times C. Yes, A times D minus B times C. 1 1/8 element times the 2 2/8 element minus 1 2/8 element times the 2 1/8 element. AD minus BC. Let's try it out with numbers. Here's matrix C. What will the determinant of C be equal to? It will be the product of these two elements. That's 1 times 3 minus the product of these two elements minus 2 times -1. The product of these two minus the product of these two. This will equal 3 minus -2, which gives us 5. The determinant of matrix C is 5. Now I want you to try out the next problem. What is the determinant of matrix D? Pause the video and find the determinant. This product is -1 times -2, and from this product we subtract the product of 3 and 4. This will equal 2 minus 12, which gives us -10. The determinant of matrix D is -10. So finding the determinant of a 2 by 2 matrix is also not that difficult. But what about a 3 by 3 matrix? How do we find the determinant of a 3 by 3 matrix? We see that in the next session. How do we find the determinant of a 3 by 3 matrix? We have seen how determinants of 1 by 1 or a 2 by 2 matrices are calculated. If we have a 3 by 3 matrix like this, how do we find its determinant? It's really interesting. Let's zoom out and find the determinant of A. Now listen to this very carefully. I will be showing you one of the ways to solve for the determinant. We will look at the other ways in another video. Okay, let's go. We find the determinant keeping the first row as the reference here. The first element is A. Now the element A will be multiplied with something. Multiplied with what? The element A is the 1/1th element. First row, first column. It will be multiplied with the determinant of whatever remains after excluding the first row and the first column. We exclude the first row, we exclude the first column, and what remains is a set of these four elements. A will be multiplied with the determinant of EF, HI. And we know how to find the determinant of a 2x2 matrix. A is present in the first row and the first column, so we wrote the determinant of whatever's left after excluding those two. Wait, it's not over yet. Then we subtract the product of B with something. But with what? It's present in the first row and the second column. After excluding them, these four elements remain. We multiply B with the determinant of DF, GI. And to this, we add the product of C with something. Now why don't you guess what we will have here? Yes, we exclude the first row and the third column, and these four elements would remain. We would multiply it with the determinant of DE, GH. This is the formula for the determinant of a 3x3 matrix. A multiplied by this determinant minus B multiplied by this determinant plus C multiplied by this determinant. Looks really difficult, right? But it isn't if you remember what I told you. Whatever element you take, exclude its row and its column and multiply it with the determinant of what remains. Solving it further, it can be written like this. This determinant will equal EI minus FH. This will be the DI minus FG, and this will be DH minus EG. This is the formula for the determinant of a 3x3 matrix. First row, plus minus plus, and multiply with respective determinants. Let's try out an example with numbers. This is a 3x3 matrix A, 3 rows and 3 columns, and we need to find its determinant. How do we calculate its determinant? Let's keep the first row as the reference. 1, 1 and minus 1. To start, we need to multiply 1 with some determinant. The determinant that we get after excluding this row and this column. It will be the determinant of this. 4 times 0 minus 3 times 1. From this we subtract the product of this one with the respective determinant. The determinant of what remains after excluding this row and this column. 2 times 0 minus 3 times minus 2. The only element of the first row that remains is minus 1. We add the product of minus 1 with something. Pause the video and find out what we will have here. After excluding this row and this column, this is what remains. Its determinant will equal 2 times 1 minus 4 times minus 2. Yes, the value of this will be the determinant of A. Let's calculate it here. 4 times 0 minus 3 times 1 will equal minus 3. So we have 1 times minus 3 here. 2 times 0 minus 3 times minus 2 is 6. So we get minus 1 times 6 here. And minus 1 times 10 here. Minus 3 minus 6 minus 10 will equal minus 19. The determinant of this matrix A is minus 19. Was this the only way to solve for the determinant of a 3x3 matrix? Probably not. We will continue this further in the coming lessons.